Hello and welcome to another Royal Math video. Today we will be discussing the factorization of a fourth degree polynomial with synthetic division. Now the problem that we have today is to factorize the following equation. Now here we have 6 x to the power of 4 plus x cubed minus 25 x times by x squared minus 4x plus 4. Now we need to find a really good and nice simple way to factorize all this expression into brackets. Now the solution is over here. Now let's find out how to get from over here all the way down to here. Okay, so step 1 is to find the constant in the equation. Now the constant will be this value over here, which is 4. So first we have here 4. Okay, so what we do is write down all the whole numbers that go into 4 when multiplied, and also divide each of these by the highest term coefficient. The highest term coefficient in this case will be 6 because it's x to the power of 4, where all of these x to the powers are obviously smaller, so we'll pick this one. So the whole numbers that go into 4 are 1, 2 and 4. Remember, it's plus or minus, and it also says divide each of these by the highest term coefficient, which is 6. So it will be 1 over 6, 2 over 6 and 4 over 6. Step 3 is to make a synthetic division table with all the coefficients of the term x in order. So it will be 6, 1, 25 and 4. So it will be 6, 1, minus 25, minus 4 and 4. Okay, this is the synthetic division table. Right, so step 4 is to choose a factor to use in the table. Start with an easy number from here, so pick a good and easy number. Start with an easy number like 2 in this case, so we will begin with 2. So what we do is put 2 on the left hand side of this table. Now step 5 is to bring the first coefficient down. Okay, and step 6 is times the number brought down by the chosen factor to carry it to the next section and add it to the next coefficient, bringing the answer down, and then we need to repeat the process. So going through it step by step is to bring the first coefficient down. So 6 comes down here, and then to times the number brought down by the chosen factor, which is 2. So 6 times by 2 is 12, and to carry it to the next section and add it to the next coefficient, bring the answer down, repeat the process. So 6 times by 2 is 12, right over here, and then plus 1 is 13, and then we just repeat this process. So 13 times by 2 is 26, and then 26 minus 25 is 1. And then we do this again. 1 times by 2 comes over here as 2. 2 minus 2, sorry, and then so we do 1 times by 2 is 2, and then minus 4 plus 2 is minus 2, and then we have again minus 2 times by 2 is minus 4. 4 minus 4 plus 4, or plus 4 minus 4 is 0. Okay, now this 0 is really important, because if the remainder is 0, then the factor is correct, which we chose is 2, so x minus 2 is part of the expression. Now whatever the factor is, we just x minus the number that we find, or plus. So if this is minus 2, then the expression would be x plus 2. Okay, so step 7 is to make a new synthetic division table using the results from the previous table and complete it using another selected factor, which in this case will be minus 2. So here we can say we can try minus 2, which is from the selection of the functions before, and we take these numbers over here. So a new synthetic division table where 6 is here, 13, 1, minus 2 all come down. So now we do it again as we did before, where 6 minus 2 is equal to minus 12 plus 13 is 1. And again, if we do 1 times by minus 2, which is minus 2 plus 1 is minus 1. And then we do minus 1 minus 2 is 2. This is because a minus times by a minus is a plus. So then 2 minus 2 is 0. So because it is 0, the rule is then the factor is correct. The factor is minus 2, so x plus 2 is part of the expression. Like I said before, the signs are reversed when you are relating it to x. So if the factor is 2, is x minus 2. If the factor is minus 2, then it's x plus 2. Okay, now step 8 is to convert the results of the table into a quadratic formula. So we had the results over here from the second syntactic division, which was 6, 1 and minus 1. Now what we do is times by x in a quadratic formula, so it will be 6x squared plus 1x, or just x, minus 1, which we have over here. And then step 9 would be to factorize this formula. Now this formula is very easy to factorize, where it's clearly 2x plus 1 and 3x minus 1. This is because the two that go into 6, when you times it, is 2 and 3, but when you plus or minus them, they are also equal to 1. So that's why we have 2x plus 1 and 3x minus 1. If you are struggling with this part of the steps, please refer to my factorization step-by-step guide. So step 10 is bring all answers of syntactic division tables into expressions. So where we have these two, and we'll also have the x plus 2, and we'll have the x minus 2. So altogether 2x plus 1, 3x minus 1, x plus 2, x minus 2. This is the solution, and we have successfully factorized this polynomial expression. I know this does take a few tries, especially if you don't get the right factors in, but this is definitely one of the most enjoyable, or even the most easiest ways to find a way to factorize complicated polynomial expressions. Thank you for listening and watching. I hope you learned something new today. Please like, share, subscribe, you know the drill, and comment down below. Let me know your thoughts on the video. Right, thank you.